Hello everyone, welcome back to lecture. I'd like to go over lesson 2-1 today, and we're just going to go through the main topics, and it's basically about recognizing patterns and using them to make predictions, but the part that I'm going to cover most is just distinguishing between linear and exponential growth. This is the most important part of it. So let's get started. Let's hop down here. If I offered you one of the two accounts detailed below, which would you choose? Most importantly, why would you make that choice? And in account one, here is, say you deposited some amount of money in account one. This is your start. And then after 1 year, you would get some interest added to your account. So you've got $1,060. And then after 2 years, $1,120. After 3 years, $1,180. After your 4 years, $1,240. And over in account two, you put the same $1,000 in. At the first year, you've only made $50 worth of interest. The next year, you have $102.50. That's your $1,102.50 in the account. $1,157.63. And then you get $1,215.51 at your account. And it looks like this is slowly starting to build up. But how could you tell, and how would you be able to see if there's any, is there any advantage to either one? So it looks like account two, if you plan to leave the money in for many years, because this is called compound interest. This will eventually catch up with and pass the balanced growth in account one. If I look at this, let's see what's going on. If I look at this version, what I do, if I subtract any one of these years from the previous years, I'll see the same amount of money. So I have $1,060 minus $1,000. I've got $60 that I've been deposited, that I've added to the account. And then $1,120 minus the $1060, I see the same 60. Here, if I do the subtraction, I get the same 60, and then again the same 60. But here I see something a little different happen. If I do the subtraction, I see 50. Then I see Then I see 52.50 between years two from the year one. And then if I subtract here, I'm getting 55.13. It looks like. And then I continue on. So these aren't the same amounts. What'll happen though, if I divide, basically after 1 year from this, if I divide and divide and divide and divide, what I'm going to find out is that each time I get multiplied by the same factor. That multiplication is called exponential growth. And that's usually what happens in compounding interest. I make money off the previous money. I'll put it back in. Here I put that $1,000, and the only thing they're going to pay me interest on is just $1,000, and I keep getting $60 on it. So let's look at some patterns. Describe the change from one number to the next in this pattern. So if I go 2, 5, 8, 11, 14, 17. So if I'm looking at what's happening between one number to the next in this pattern of numbers, in this series of numbers or sequence of numbers. I get 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3. So each number adds 3 to the previous number. If I look at this sequence of numbers, 2, 6, 18, 54, if I divide 6 divided by the previous is 3, 18 divided by 6 is 3, 54 divided by 18 is 3. So what is happening is that I'm multiplying each one of these numbers by 3. 2 times 3 is 6, 3 6s is 18, 3 18s are 54. 3 times 54, if we get our calculator, is going to be 162. So each number is the previous number multiplied by 3, and this is an exponential growth, and this is a linear growth. All I'm doing is adding a 3 to each one. So in the first list, the value grows by adding the same constant number. That type of growth is called linear growth. And in the second, the value grows by multiplying by the same constant number, and that type of growth is called exponential growth. So which one is given it? Is exponential growth always going to result in faster growth than linear? Think about this for a little while. Linear may grow faster at first, but exponential will in the long run be better. I mean, it will grow more. It just may take some time, but then eventually it'll start catching up. Remember when we looked at that 2-1? The linear count grows by 60 each year. The exponential count grows by more and more each year, and eventually will take over that 60, and you will basically be making more money off of it. So if you're giving a sequence, what are the two things that you're going to look for? If I can take the previous number and subtract it, and I always get the same thing. 45 minus 35 would be 10, 55 minus 45 is 10, 65 minus 55 is 10. The next one, they're always adding 10 to it, so I would know that this next one would be just the previous plus 10 to predict what the next one would be. If I want to do this in Excel, I can also do the previous plus 10. So in A5, I could go equals A5 plus 10 for the next one in A6. Okay. So for A6 equals A5 plus 10. I can also, since it's 10 each time, I could say it's 35 plus the 10. So if I wanted to know what would be in A12, I would just do the 75 plus 10 times, ever how many the difference of it would be, because I'm just adding that many times. So for instance, this would be 35 plus 1, 2, 3, 4 times 10 would be the 75. Here's the example of exponential growth. If I subtracted 20 minus 2, I'd get 18. 200 minus 20 would be 180, and this would be 1080. But if I divide each one, 20 divided by 2 is 10, 200 divided by 20 is 10, 2000 divided by 200 is 10. I'm seeing I'm multiplying each one of these by 10, and it's really starting to grow. Okay. If I wanted to do the next one, it would just be A6 equals A6 times 10. And look at this. This would be 10 to the 1 times 10 squared times 10 cubed times 10 to the 4th times 10 to the 5th. What value would you appear in A12? We just keep doing this by tens. And again, if I'm starting with this, I would just go 10 to the 1, 2, 3, 4, 5th, 6 times 10 to the 6th. Suppose that you're offered two jobs by a very eccentric but lovable billionaire. One pays $40,000 in the first year with a salary that increases by $10,000 every year. And the second one only starts out at 50 cents a day. And your author says, which I imagine probably violates minimum wage laws, but it doubles every month. Which job would be more inclined to choose and why? So most people would choose the first. Well, if I'm going to make $40,000 at first, I'm going to get $10,000 extra raise every year. Let's go with this one. But this turns out to be an exponential because I'm doubling. I'm times 2 each time. Okay. So let's just prove it. How much would you make per month in the first year with a $40,000 a year job? 40,000 divided by 12, that's 3,333 per month. And going with a 30-day month to keep the calculation simpler, how much would you make in your first month on the second job? Well, they said if you just did this, you'd only have 15 per month. But remember, we're doubling at 50 cents a day. So what they're going to do is say, here, month 2, doubles every month. Sorry, doubles every month. We start out with the 15 the first month, and then I'm going to double it. The 15 times 2 times 2 times 2. Here we keep the same amount until the end of the first year, and then we just add the extra 10,000 divided by 12 here. But here, notice the exponential. 30 divided by 15 is 2. 60 divided by 30 is 2. 120 divided by 60 is 2. So I'm multiplying times 2 each time. And look, by the end of the first year, just by doubling that amount for each month, I'm already at $30,000 just for the month. Okay, so we've overtaken monthly salary by the end of month 9. Okay, so that is the basics of linear and exponential growth. Remember, the linear, you're just going to subtract the previous, and if they're always constant between the two, you can just add, continue to add. And if exponential growth, the signature is that you're always multiplying by the same number. So you should be able to divide each sequence, each number by the previous, and you always have that multiple. Okay, so we'll see you at 2.2. Have a good day.